So let's say China, Russia, our enemies have this capability. We have this capability.
If we get this capability a year ahead of adversaries, we're just going to be able to respond so much faster. Imagine we were playing chess, but for every one move you take, I can take 10 moves. Like, I'm just going to win.
It war games at real time.
Exactly. It'll war game at real time. You can run these war games and these simulations a million times.
So is it just AI after AI after AI that's doing all of this?
And then we started working with the DoD on, more ambitious and larger scale AI projects. So one of the things we're working with them now is this program called Thunderforge, which is using AI for military planning and operational planning. So more broadly, so the basic idea here is, can you use AI to effectively automate major parts of the military planning process so that you're able to plan within hours versus taking many days?
This sounds like Palantir.
It's, they target different parts of the problem and we target different parts of the problem. And ultimately we work together pretty well. But this is part of a broader concept that we have around what we call agentic warfare. So the use of AI and AI agents in warfare. And the basic idea is, can you go from these current processes where humans are the loop to humans being on the loop? And so can you go from, situations where, these workflows have to go from a person has to do a bunch of work, then pass the next person, they have to do a bunch of work, pass the next person, to the AI agents are just doing a lot of that work and humans are just checking and verifying along the way. And it's a big change. So going from, if you compare both setups side by side, here you have individuals, humans with decades of single domain experience who are doing each step of this process. And then if you have the AI agents doing it, ideally you have AI agents who have, thousands of years of knowledge, all domain knowledge, and are 1,000 times faster at doing the actual tasks. And so it's all about taking, and this exists at many, many different levels. So, you can think about this for the sensing and intel portion that we were talking about before. So, can you accelerate the intelligence gathering, the process by which we take all of the sensor data and turn that into insight? You can think about it for the operational planning process, like how can you accelerate that entire flow. You can think about it in terms of, on the tactical side, how do you accelerate tactical decision making? So it bleeds into every sort of level of warfare, every component. But at its core, how do you use AI agents to be faster, more adaptive, and have humans just check their work?
So when you're talking about it helps with mission planning, especially in a tactical environment, because that's where I come from. I mean, what is, it could be any example, but can you give me an example of how it speeds up the mission planning process in a tactical environment?
Yeah, so let's say that, so this thing that we have, by the way, we're working on it with INDOPACOM and EUCOM right now, and we'll deploy it more broadly. But let's say that there's what's a good example? Let's say there's some kind of alert that pops up. Like there's something that we didn't expect that we need to figure out how we're going to respond to.
Like what kind of an alert?
So, I mean, let's say there was there's you can imagine at different levels, but let's say there's a ship that popped up that we didn't expect.
Okay.
As a simple example. So then that alert flows into a bunch of AI systems that are the first step is sensing. So let's look through all of our sensing capabilities and let's go reanalyze all of the data that we have and figure out how much do we know about that ship, right? So now a person would, an analyst would go through and do all this, all the PED and all the stuff to be able to undergo this work. But ideally you have AI agents that are just they can look through all the historical sensor data. They can figure out, actually there's kind of a thing that showed up on this radar and there's kind of a thing that showed up on this satellite imagery. And we can kind of sketch together this, the trajectory of this ship. Okay. So you go through that process, you try to understand what's going on. And then you go through and figure out, okay, what are the possible courses of actions? So once you have situational awareness, then what are the courses of actions against this particular scenario? And you can have an AI agent honestly just propose courses of actions. Like, hey, in this scenario, given this ship is coming here, we could fire at it. We could just wait to see what happens. We could reposition so that we're able to handle the threat better. All sorts of we could reposition some satellites so we have greater sensing. There's all sorts of different courses of actions that we could take, and then once the AI produces those courses of actions, it'll run each of those different courses of actions through a simulator. So it'll then run.
So it war games at real time.
Exactly. It'll war game at real time. And so then it'll run there through a simulator and say, okay, what's going to happen if we fire at it? Like, this is what we know about red forces. This is what we know about blue forces right now. If we fire at it, this is this is the war game of how that plays out. If we just increase our sensing, like, these are the things that the red forces could do to fuck us up. And that's the risk that we take on. And then the benefit is, because all of this is automatic, you can run these war games and these simulations a million times. So it's not just like one, military planner is just trying to war game and plan it out in human time. It's like you could run a million simulations because you don't have perfect information, you don't have perfect knowledge. So you need to kind of figure out, based on the uncertainties of the situation, what are all the potential outcomes that pop out of that.
Wow.
And then, so you run a million different simulations of each of these different courses of action. And then you can give a commander direct, you just give them this whole, brief and presentation, which is basically, these are the courses of actions we considered. These are the likely outcomes in those courses of action. We can show you the simulated, outcome in each one of these scenarios. So we can show you what it would look like in every one of those scenarios if it happened, representative simulations, and then the commander makes a call.
Wow. So this is what it is. This is what it's doing. These are the possible courses of action. These are the consequences of each action. This is the percentage.
Yeah, exactly.
And it spits that out in what, a matter of seconds?
Then now it takes probably takes, even now, it probably takes a few hours because, these models are a lot slower than they will be in the future. But yeah, compare that to, depending on the situation, that could take days for humans to do today. And it's not from lack of will or effort or capability. It's a really complicated situation. If a ship pops up out of nowhere, there's a lot of stuff you have to consider. And so that's really the step change here, is just a dramatically accelerating situational awareness, dramatically accelerating an understanding of what the different course actions are, what could happen, what are the consequences, and surfacing that to commander.
Does it make a recommendation?
This is kind of an interesting thing. We go back and forth if we want to make a recommendation, because ultimately, we don't want to just be we don't want to let commanders kind of sleepwalk, if that makes sense. We want them to our military commanders are the best humans in the world, considering all of the potential consequences of these different courses of action, and also considering, and ultimately making a call based on those potential consequences. So I think we want to ensure that commanders are still exercising their judgment in these decisions versus just, making it easier for them to just say, oh, go with what the AI says.
Interesting. Wow.
But then, okay, think about what happens next. So, and this is where stuff gets really freaky. So let's say that, obviously in a world where just the blue force, just the United States has this capability, that's great. We're gonna be running circles around everyone else. But then what happens if the red force, China, Russia, whomever, also has that capability? Then you're in this situation where I've war gamed out the whole situation. They've instantaneously war gamed out the whole situation. And then it's I honestly think, so then it's we know and like blue forces, red forces, we both know that we both have like, these perfectly war game scenarios. Which avenue do you pick? And then it becomes this really complicated, almost like psychological, kind of situation, which is like, then it like all comes down to how good our intel is. So how good is our intel about that commander? How good is our intel about what their collection capabilities are? How good is our intel about, what they likely know about us, and vice versa? And it gets pretty.
So this is actually, let's just, so let's say China, Russia, our enemies have this capability. We have this capability. Then it kind of becomes, it's like the same process that we deal with now. Who has the better intel, right? It's just developing and you're going to a course of action quicker, and the enemy's doing the exact same thing quicker. So it's essentially the exact same thing that we're doing now, but faster. And so if we develop it first, then we achieve basically global domination. Am I correct here?
Yeah, I think timing really matters here, because if we get this capability, and this will go for, I mean, there's way more AI we'll be able to do, but let's say we get this capability, a year ahead of adversaries, then we're just going to be able to respond so much faster. The analogy I often use is like, imagine we were playing chess, but for every one move you take, I can take 10 moves. Like, I'm just going to win. Mm-hmm. And that's the asymmetric advantage that comes out of this capability. And then once it equalizes, then it's like this very, it's like, to your point, it becomes this like adversarial, intel-based, capability-based kind of conflict.
No matter where you're watching Shawn Ryan Show from, if you get anything out of this, please like, comment, subscribe, and most importantly, share this everywhere you possibly can. And if you're feeling extra generous, please leave us a review on Apple and Spotify podcasts.